See you all. So let us talk a little bit about Thanksgiving. So what it sounds like. You sound a little raspier. Ooh, maybe I got to get the microphone closer to me. Raspy. Yeah, I had lunch. Maybe that's it. I so tell me, what is your favorite dessert at Thanksgiving? Good afternoon, Ty. What's your favorite dessert? Thanksgiving dessert. Mine is pumpkin pie. Anybody like pumpkin pie? All right, 100%. Yes, got 100%. Now, pecan pie, my brother-in-law makes it. Hey, Gavin, my brother-in-law makes it, and it's pretty good, but it's too sweet, really sweet. It's like if you could make pecan pie less sweet, I would love it. I don't know if you can. It sticks together, right? All right. So, hey, Caitlin, and let's see, Naya. Good to see you guys. So, so what we're gonna do, I just want to just kind of go over some things with you here. So, when we talk about ionic compounds, okay, ionic bonds. Remember, it's a metal and a non-metal. That was from last week. So remember, but you got to use the periodic table, right? So now we're talking about they're transferring electrons. So they transfer. So it's like taking another plane. You're taking an electron and moving it somewhere, right? And covalent, right? Valent is the shared electrons, and that's because we can't make an ionic bond out of those because they are two nonmetals, right? Nonmetals, right? So let me show you this. The reason I'm showing you this is because I want you to do this little game with me. Let me share this with you. Okay, let me share this with you. Copy this, copy that. Practice, practice, practice. Hey, Jasmine. So let's do this together. You need to use the p table with this as well. So having a periodic table, it comes in handy. Remember, on the periodic table, the green here is this green p table. I'll show it to you. So if you want to, let me get this. Okay, come on. Copy. Here is the periodic table here for you. Okay, so when you look at this, if you're looking for nonmetals, okay, if see a hydrogen over there in the corner, on the left-hand side is green, so that's a nonmetal. You can see that if it starts with a hydrogen or a carbon or a nitrogen, then it's covalently bonded. But if it starts with anything over here, any of the metals, like lithium, beryllium, not in the green, again, right here, this is the metals. Oops, I'm on the wrong side here. You go all the way to aluminum down that stair step. It starts with a metal like lithium or silver or copper. Then it's a ionic bond. So, okay, just want to let you know. So let's do this. I'll show you this. Okay, so let's start this together. And I'm going to turn my screen off. So you get to move this guy up or down. HCl is covalently bonded because it's hydrogen. It's not ionically bonded. Got to watch out. But that's on a non-metal and a non-metal. So on your periodic table, try not to hit the clouds. NaCl is ionic, right? Ionic because it's got a metal first. Iron. Iron is a metal, right? Iron is a metal. So that means not non-metal, and is not covalent. So non-metal is so this is ionic. And it's a metal, non-metal. All right. Next one, K and I. Potassium is a metal, so it is ionic. So if I hit this, bang, oh, see, I get 3 tries, right? All right, it's also a metal and a non-metal. So if I hit metal and non-metal, good job, I got it. But I'm smoking silver and nitrogen is ionic. Now I'm going to hit, oh, I made it. I just hit the top of it. Chlorine and oxygen is a non-metal. So if I hit metal, not metal, non-metal, oh, see, I'm even smoking more. So remember, chlorine is on the right-hand side. It's covalently bonded. All right. And it is non-metal. C and O are both on the right-hand side, so it's going to be covalently bonded. H2O, that is a non-metal. Hydrogen and oxygen. Find another answer. H2O is covalent. Oh, pow, I scared myself. Wow. I tried to land into that covalent. Okay. But again, like I said, you got to get either a printout so that you can do that, or, just slow down, because you got to recognize. Now, again, I have, been doing this for a lot of years. I didn't do well in chemistry in high school when I took it in 10th grade, but I made up for it by teaching it. So it's because I know what it feels like to mess up. I messed up a lot. All right. So what we're going to do today, ladies and gentlemen, we are going to start this assignment here. Okay. And we're going to do some practice on covalent, trying to understand it. And then we're going to open up a game, not a game, a breakout room to breakout room so that we can go over the exit quiz from yesterday. So if you didn't do well on the exit quiz yesterday, um, then I'm going to ask you to come in. It's not mandatory. I don't want to make you feel uncomfortable. If you can do it on your own, you can. But again, I'm offering the help. So if you can get in here, we got 17 people in here. Can we get in there? I know you guys are working on this. Hey, Zaria. Zaria, thank you. Victoria, Ty, Tanisha, and who else? Mariana, good to see you. Kamaya, good to see you. All right, let's go. Let's start the class here. Small class today. All right, and okay, so here's the periodic table, remember? Okay, and the nonmetals are all in yellow, right? These are all the ones in yellow right here. Hydrogen. So again, like I said, if you have H2O, all right, and that's, you got hydrogens, they're both in yellow. If they're both in yellow, it's covalent. All right, and if they are both, if they're metal, like Na is a metal and Cl is a non-metal. So remember, this is non-metal and non-metal. Okay, here it's a metal and a non-metal. Okay, now that's ionic. So you've got two different, if they have two different colors, it's ionic to the same color, except for we haven't talked about two metals, but again, two different colors, and green and yellow and yellow will make your covalent and ionic. Okay. So elements that have the same group have the same electron dot structure, right? So all the ones that are in group 1 and 2 are metals underneath the hydrogen. They want to lose electrons, right? They want to lose electrons. And the ones on this side, on the right hand of the periodic table, they want to gain electrons. So those are the nonmetals. The nonmetals want to gain. Nonmetals want to gain, right? So, and you can see they have more. Carbon is 4, nitrogen has 5, Oxygen has 6. Remember, we just take the 1 off, and then we have the 6. Right? And remember that atoms want to be stable. And the way I look at stable is like a table, right? A table that has 4 legs, right? If I did a table with 4 legs, it'd be a stable table, right? 1, 2, 3, 4 legs right here. 4 legs will be stable. Now, if it had 1 leg left, it would be unstable, untable. That's what I like to think about it. Same way with elements. Sodium has 1, wants to get rid of it because it's a metal so that it'll become stable. Chlorine has 7, wants to gain 1 to make it 8 and stable. So 8 makes them happy, right? 8 and sometimes 2. Hydrogen is, and that's what they call the octet rule. The octet rule, the octopus rule. The octopus rule says for some reason, when atoms have 8 electrons in the outer shell, they become a stay table. Stay table, get it? Stay table. The table stays, giving them the same electron configuration as the noble gases, which have all 8, and they don't react with anything. All right, so the process occurs when atoms share. So thinking about sharing is caring. You've got atoms like this is hydrogen. Hydrogen shares electrons, not transfers them, not sends it over. If it were to send it over, it would become positive, and this would become negative. Then they would be stuck together by electro forces, but they're not. They're sharing. They don't have any. The charges are neutral here. So, and it becomes a molecule rather than a covalent formula or covalent compound. So here we have the sharing goes on. You can see it more in this slide here. Where is this slide? Right, here we go. You can see it kind of bonds together and shares like the Venn diagram. So there's 1 electron from each. They match up, and then they are sharing from each other here. All right. So let's take a look at this real quick. All right, here we go. So atoms are the smallest of matter. Okay, so here is a diagram of atoms, atoms of carbon, oxygen, hydrogen, the smallest unit in an element. So we're going to depict that as a circle with a C for carbon, a circle with a H for hydrogen, and an O for oxygen. Now, when they bond together, okay, they become molecules. Molecules are made up of more than 1 atom. Atoms of the same or different element that bond together are called molecules. And you notice that molecules encompass this whole thing. So it's a Venn diagram where molecules are the same as compounds. It says molecules could be the same or different, but then we give another name for the things that are different. Compounds are made of more than 1 atom that are different. So H2O. It's like um, a four-sided figure can be called a rhombus, or a four-sided figure could be called a rectangle or a square. Same thing here. A molecule could be called H2O, but we could also call it H2O compound. But we can't call H2 or hydrogen a compound because it's the same. It's just a molecule. So that's what we got here. So let's go back here and see if you guys can match these up. And I'll take points on those people that are participating. I got how many people here today that are participating? Not many are here today. We only have 18. 6 hours so hard. I bet you 7th hour is even harder if you're taking 7th hour. All right, so let me see who's in here. Is there anybody in here? I don't see anybody in here at all. So maybe we have such low participation we don't have anybody. All right, so let's see what we got here. Thanks, guys, for coming in. For sure, participation. I know you have to delay gratification. Thanks, Jasmine. Delay gratification here today because you know you have to wait till the till January 12th to get your 50 points. Thanks, Jasmine. Keeps you on track for sure. Thanks, Kamaya. Thanks so much. And we go, pair deck. And we got Zaria. Where are you? Zaria. All right, pair deck. And anybody else? Yeah, Renaya. We have also. All right, and that's it. 3 out of 6. Oh, wait a minute. Did I get another? Kamaya, Jasmine, Daria, Renaya. Okay, so let's take a look at what we got here. So element, substance with only one type of element, a compound, 2 or more different atoms, and a molecule, 2 or more joined chemically, 2 more atoms joined chemically. Okay, so let me take a quick look at this just to kind of make a distinction between the ionic compounds. The molecule is covalently bonded. A molecule is talking about covalently bonded. All right, so notice the carbon atom, that's a non-metal. It's on the right-hand side. Fluorine is a non-metal. It's on the right-hand side. Okay, it can't be bonded because they both want to be gaining, so we have to find a different way of bonding those. All right, and here it is. So we have the blue. So at these points, we put 4 fluorines. Okay, so now fluorine has 7, but by sharing it with carbon, it has 8. It's happy now. And here, fluorine also happy. Oxygen is also happy because it has 8. Fluorine is happy, and also all 4. So we write the chemical formula for this as CF, and there are 4 of them. 1 to 1 carbon, there are 4. And a molecule of carbon is called this is the name of it, carbon tetrafluoride. Now, the "ide" part, you're used to. We put the first element name in the front. But here is the naming here is a little bit different. We use a prefix that says 4. This basically says carbon with 4 fluorines, carbon tetrafluoride. And we'll be talking about this tomorrow. All right. So this is how the bonding happens here. There's no transfer. Transfer goes like this. Na has an electron, transfers it over to Cl, who has 7 electrons. It got an extra one, so it's holding on to that. Now it becomes negatively charged. This becomes positively charged, and they're stuck together like glue because of the charges. This has no charge to it, no charge. All right. They both gain. Here, sodium wants to give, the metals want to give up. And that's why you see no metals in covalent bonds. Right? Here's water doing the same thing. Right? Okay, so let's see how you guys are doing in the hey, Gavin. Yeah, I fixed it, I think, Gavin. Thanks for asking. Thanks for asking. I fixed it. I messed up on that. I think it'll work today. All right, so let's take a look at this as a poll question. All right, which of these we've been talking about, if you know what I've been talking about, what kind of elements gain electrons? What kind of elements gain electrons? Control, copy. Let's put it in a poll question here. Poll question. What kind of elements gain electrons? All right, so A, B, C, D. What kind of elements gain electrons? Let's take a look at the presentation here. A, metals. B, nonmetals. C, both metals and nonmetals. Or D, noble gases. All right, so let's see what we got here, okay? All right, so we've got, hey, thanks, Jasmine. You guys are in the pair deck already. Let's see if we can get Aaron and Anaya and Bradley. Donovan and Gavin to put some votes in. What is it? A, B, C, or D? Caitlin, Madison, Maria, Tanisha, Ty, Victoria, get in there, please. Thank you, guys. Thank you much. Kamai, you already put your vote in the other one. You don't have to do this again. I'm looking for those other people like Aaron, and thanks, Aaron. All right, see how well you're paying attention here, okay? And it also tells me if I need to readjust here. So we've got Gavin, Donovan, Saria, and Kamaya, Jasmine, Aaron. Okay, looks like we've got, and then we got, who else did we get? Mariana, thank you. Okay. So this is a non-metal thing, right? Okay, non-metals gain, right? Non-metals gain. Metals lose. Okay, so that's why we're talking about covalent bonding, because we're putting together non-metals. So if you can remember anything, non-metals are the covalent. All right, so here it says what kind of element gains? It's the non-metals, the green and the hydrogen, right? Okay, so let's see about this element here. Let's see if we can do this question here. Paying attention. Thank you guys for paying attention here. Where are you? Question. Which type of bond formed between these elements? Okay, and again, this is using your periodic table. This is kind of one of those questions that you will see on state exam, right? Come on, copy, control, paste. Okay, start a poll. Okay, I can't do it until I do this. There we go. A, B, and C. Okay, start a poll. All right, so which of these, A, B, or C, is form this? So this is, okay, let me help you out here, ladies and gentlemen. This is non-metal over here, right? This is a non-metal. And this hydrogen up here is a non-metal. So what did we just say about non-metals and non-metals? What did we say about non-metals and non-metals? All right. Okay, most of you, thank you guys for doing that. Most of you got it right. It's a covalently bonded. Okay, it kind of snuck in here because remember, metals are right here. Up to this point are the metals, right? But that hydrogen is not a metal. So it's a non-metal and a non-metal. All right, let's look at this next one here. Okay, so non-metal and non-metal are covalent. Metal and non-metal are ionic. Okay, so we're close to the end of these slides. So if you can see the Lewis dot, oxygen, if you look at the periodic table, oxygen is in group 16. So we cross out the 1, we get 6 of these. Hydrogen is group 1, has 1 electron. They end up sharing. So this has 8, and these have 2. Remember, full shells of 1 shell are just 2. Now, what we can do with these, we can represent these as dots, like the Lewis dots, or we can represent these with a bond. So bond, like 2 dots, we can replace with a line. 2 dots per line. And that's the same thing as their covalent bond. It's a single covalent bond. So the different types of formulas, we have the chemical formula or molecular formula, just like we have CO2. Okay, we can do CO2, that's the chemical formula. H2O, this tells us the ratio, 2 hydrogens to 1 oxygen, or a 2-to-1 ratio, hydrogens to oxygen. Or we can draw the structural formula, and we can see the electrons here and the bond in between them. Structural formula says a single bond with two non-paired electrons. And those non-paired electrons show up. So these are all non-paired electrons around the chlorine and a bond between them. And we write the chemical formula for this as Cl2, two chlorine atoms bonded together. Now, here is a single bond represents the shared electrons, and these are lone pairs or pairs of electrons that are not bonded to anything. So we do have a full 8, 2, 4, 6, 7, 8 here. And again, I showed you the chemical formula for this as Cl2. Okay, so we're done here, ladies and gentlemen. So let us stop here for a second and I'll show you what you're doing next. Okay, so in the student version, you need to read through this assignment here and answer the fill in the blank questions here. Okay, I'm going to give you this as a student paste so you can go back and forth and find the answers there. Okay, so I'm going to give you that to do. And then I'm also going to do a breakout room, right? A breakout room. So this is the, let me do this. I'm going to clear the chat here. Clear. All right, so this is the classwork assignment. Okay, and I know that you do it. I can tell when you get it done. I can take a look at that classwork. Start working on that now. Here is the link. All right. Right, so I'm going to make sure that, and that is, I'm going to put in the shared notes as well. It's the classwork. All right. And now what I'm going to do is I'm going to put this on pause, and I'm going to open up a breakout room and go over the exit quiz from yesterday. So if, it's not mandatory to come, but I'm inviting you to go over the information so that maybe I made it too difficult, or maybe you misunderstood the drawings that I made. So let's talk about it. I really appreciate it when you guys come in. Off here in a second. Thanks for coming into the chat. Everybody else should be working on the assignment that I linked for you guys. Here, come on, stop. There we go. Yep, still muted. All right, so here are the notes, ladies and gentlemen, that you were filling out. So if you didn't get those, there you can, I've got those for you. All right, so, and any questions on the notes or the assignment? Okay, we do have one more game for you. If you want to play this game, I'll show you where that is in a minute. Oh, that's okay. I was muted for a while, so yep, I was muted for a while. I was muted twice. I thought I clicked on the thing to go. So, okay, guys, you are free to go. So Cami, text to speech W12 assignment 1 is a text to speech one, and W12 assignment 2 is also text to speech. If you don't worry, if you want to see all the notes, that'll help you on all 3 assignments there. It's pretty long, but it is in here, all the notes for the covalent bonding. All right, guys, have a great day. Thanks for coming. Thanks. As Gavin says, have a great day. Everybody have a wonderful day, and God bless you all. Thank you.